Hello guys, welcome to Sumo Code. So today we are going to learn about what is RAG, Retrieval Augmented Generation. So what is RAG? RAG is nothing but an AI framework that combines the power of an information retrieval system, which is nothing but a database, with the generative AIs, which are LLMs. So what RAG is? RAG is a combination of a database, which is nothing but an information retrieval system, along with an LLM. So this is what RAG is. So now what RAGs helps us in achieving? It improves or enhances the power of the searches that you can do using the LLMs. Searching power is improved highly. So how are they done? Because LLMs have some limitations. So what are the limitations of these LLMs? LLMs are trained on outdated data. The data on which they are trained on are not recent. They are also trained on public data. So this is also one more drawback. Third one is that there is a limit on the tokens that you can send in one request to these LLMs. So limited context is also there. Like for ChatGPT 4o models, there is a limit of 128k tokens that you can send in one request. So these are the three main problems associated with an LLM. So RAG is going to help us in overcoming all these problems using an information retrieval system, which is going to be our vector database. So let's look at how it happens. So here all the problems related to the LLMs. So what we can do is, in the context of the prompt that we are going to send to the LLM or the query, we pass in the relevant information related to the query. So consider if we have a big book, like consider 1000 pages are there in a book, and we wanted to perform a search on this book. And that book has been launched recently, and the LLM do not have any information on that. Then how this will help? We, in the context of the query that we are going to pass to the LLM, we pass in only the pages related to which our question is there. So in this way, the information that would be passed into the query context or the prompt would be latest one, and also will be within the context limit of the LLM. So if we pass in all these information to the LLM, it will have a very much high chance that it will give us the correct output. So how can we pass only some of the pages which are related to our query? So that's where vector database comes into action. And using this vector database, we are going to perform the RAG. So now let's look at the RAG architecture and how this retrieval of relevant pages or the information comes in. So to do that, in RAG architecture, we are going to use a vector database. So now, to perform search on a book which is very much recent or your private documents, what we have to first do is store it in a database. So then that database is our vector database. Now how we are going to store is, we are going to chunk it into smaller parts. Those chunk can be one page of the book, or smaller parts like paragraph. One paragraph would be one chunk. So this chunking strategy depends on your use case to use case. So you are going to chunk it into smaller parts and are going to store it in the vector database of yours. There are many vector database in the market, such as VV8, Pinecone, Chroma. So all those are there. So now our first step is done, which is storage. Storing of the document has been done. Now we are going to query. So whenever we are going to do some query, along with the query, we are going to find the relevant information in this vector database. So we are going to only find the chunks which are related to our query. So this is our stage of information retrieval. So we get those chunks, we combine it with our query, pass it to our LLM. So here you can see that if we use such a system, then there are a very much high chance that we are going to get a good output, and it will resolve all these problems of an LLM as well, which are outdated, public data only, limited context. So the RAG helps us in overcoming all this. If you don't know what vector database is, I'm going to just go through a very quick description or explanation of vector database. If you want to know a bit more detailed about it, I've made a video on my channel. You can go and look at that as well. So what vector databases are? Vector databases store vectors. What are vectors? Vectors are just list of numbers representing something in a multidimensional space. What they represent? They can represent anything like text, image, audio, or video. Videos are just series of images only. So anything they can represent. Now, what is so special about vectors that can help us in finding those similar images or text? So how can that happen? Vectors of similar text, semantic Vectors of similar semantic meaning text or images are created in such a way that when they are plotted in a multi-dimensional space, they are located to each other if they are similar. So now if you query something like find similar to this keyword or this query, it will search its nearer parts and will find the nearest vectors to it, and they will give its result, which will help us in finding the semantically similar queries to the current query. So how are these vectors created in such a way that similar vectors are stored similar to each other? They are done using this embedding model. What is an embedding model? Embedding model is a neural network which is trained in such a way that if you pass text or any data to it, it will convert it into the vectors, and similar text or similar data's vectors are stored together. So using these embedding models, you are going to create vectors. Now what happens in the vector database is that if this is my vector database, data is passed in this vector database. Data would be automatically converted using an embedding model that you are going to configure in this vector database. So those data would be converted into the vectors using this embedding model that you have passed, and then would be stored in the database. So this is what happens in a vector database. Now, what are the operations that you can perform in a vector database? You can do similarity search, which is nothing but finding similar vectors. You can do keyword research as well, which is nothing but finding the most occurrences of a keyword in a chunk of text, which is also known as BM25. So you can do that as well. You can also perform hybrid search as well, which is a combination of vector and keyword search. Also, not just for text, you can also do all these things for images as well, or any other kind of data as well. So this is all about RAG, vector database. If you have any doubts, please write it down in the comments. I've tried to explain it with every detail that I know. So if you like this video, please give it a thumbs up. So thank you for watching. Bye.